Hello, welcome to the Mark Janard Show, the cybersecurity show. In this video, I'm going to break down a tutorial of how to build an ESP32 CAM. So, without further ado, let's get right into it. We're going dark. So to build an affordable ESP32 CAM device, you're going to want to follow this step-by-step process, right? Whether, I'm going to be covering components, the assembly, and the programming. Right, so this is low cost. I know you guys be it's expensive. It's a low cost. Okay, I gotcha. Right, it should be under 10 bucks, whatever. Right, there's optional motorization and then basically enclosure for enhanced functionality. So it's a minimal build structure. Right, please take a moment to hit the subscribe button and the like button. Please take a moment to hit the subscribe button and the like button. So we're going to start with the ESP32 CAM module, right? With the OV2640 camera, the FTDI programmer, that's the USB to serial adapter for programming. There's the jumper wires, which is female to female DuPont cables. The micro SD card, that's optional for the guys like, too expensive. Yeah. It's optional. But you have the micro SD card for the image storage, right? You have a 5V power source, USB charger, or battery pack. Basically that's again optional for the pan and the tilt for or enclosure, right? The micro server motor, the SG90 or similar, wires for the server, 3D printed or acrylic enclosure. That's basically for any casing. The soldering iron, that's optional for stronger connections, but if you want to maximize, you're going to want to do that. Now let's get into the parts preparation, right? You want to purchase an ESP32 CAM module and basically make sure that it includes the camera. Then you have to obtain the FTDI programmer, check basically if it supports the 3.3V logic. Then prepare the DuPont jumper wires for circuit connections. Now if you want to maximize, this is optional, but not optional, right? You want to prepare a micro server and materials for enclosure. Then in regards to the circuit assembly, right, that's wiring for the programming, you're going to want to connect the ESP32 CAM to the FTDI programmer, right, in this way. The FTDI TX to the ESP32 RX, the FTDI RX to the ESP32 TX, okay? And then the FTDI GND to the ESP32 GND, the FTDI 5V or the 3.3V, preferably the 5V, however, to the ESP32 5V, right? The ESP32 GPIO 0 to the GND, that's only during the programming part, right? Now, a pro tip is to use the female-to-female jumper wires for ease or solder for reliability. Then connect the FTDI programmer to your computer via the USB. Now, in regards to programming the ESP32 CAM, install the Arduino IDE or use the platform, IO/the ESP IDF. In Boards Manager, you want to install the ESP32 by the Espressif systems, right? You can search ESP32. Then select the AI Thinker ESP32 CAM as the board type. You want to open the camera web server example, whether it's file and then examples, then ESP32, then C, the cameras, right? And then the camera web server, right? Configure the Wi-Fi SSID and password in the code. Select the correct ports and FTDI programmer. Press the upload button to flash the code. Now, after you upload, you want to remove the GPIO 0, and the GND connection, and reset or, power cycle the ESP32 CAM. Now, the final assembly is as goes, right? Remove the FTDI and connect a regular 5V source, right? That's the battery pack or USB adapter to the ESP32 5V and GND pins. If adding a server monitor for, the pan or lit, you have to connect the server red and brown wires to the 5V and GND. Then connect the server yellow signal wire to any ESP32 GPIO, which is often the GPIO2. Then select the ESP32 CAM and server in your enclosure, right? Glue or the screws. And insert the ESP32 CAM in the enclosure. Align the camera with any lens hole. Now, in regards to usage, once powered and connected to the Wi-Fi, the ESP32 CAM will output its local IP address via serial terminal. So, you want to access the camera stream in the browser pointing at that IP, right? An example could be HTTP, 192.168.x.x. Peter, you could put that on the screen. That's just an example, right? And then the optional steps is to use the Home Assistant and ESP Home for smart, home integration. You can add a micro SD card for storing images or video. You can refine the enclosure for durability or weather resistance. That's the 3D print STL files that are commonly available. Now, there are some caveats. The ESP32 CAM does not have a built-in USB and FTDI programmer, right? Is required for programming. The power stability is best with a 5V adapter. The 3.3V may cause brownouts, especially with Wi-Fi or motor. Programming requires grounding GPIO 0 before upload, then removing this for regular operation. So, basic assembly can be done without soldering, though, soldering improves the reliability. Now, when you're going and you're building this and building that and what have you, there are potential for you to run into, troubleshooting issues, right? So I'm going to get into that right now. So, also with the solution. So there may be an issue where you run into the board is not detected or upload fails, right? Basically the timed out waiting for the packet header. Now the cause is it's potentially the data only USB cable or a wrong COM port, power issues, or the board not in download mode. Now the solution for that is to use a full data capable USB cable, not one meant just for charging. You want to ensure the correct board and COM port are selected in your IDE. If automatic bootloader does not engage, hold on the boot button while starting the upload, releasing it when prompted by the IDE. Now for a hardware fix, solder a electrolytic capacitor between the EN, RST, and the GND pins to automate bootloader entry. You want to avoid USB hubs and try connecting directly to your PC's USB port. Now, another thing that you might run into is the ESP32 randomly resets or does not boot. The causes is potentially unstable power supply, excessive peripheral current, and brownouts, right? Now, the solution to that is to use a stable power source capable of, providing at least, 3.3V or 5V, right, as required. But we really want the 5V, right? You can add a capacitor across the VCC and GND lines to stabilize the voltage. You can check your wiring for shorts or excessive device draw, right? Now, again, another troubleshooting is the serial monitor that shows gibberish or nothing. The causes of that is the wrong baud rate, port conflict, or the missing serial, .begin. Now, the solutions for that is to set your serial, monitor to the same baud rate as, in your code, which is commonly 115200, right? So ensure the serial.begin is, called correctly in your code. Verify no devices are occupying the TX/RX lines needed for programming or monitoring. Libraries not working or compilation fails is another troubleshooting. And the causes is incompatible libraries, outdated IDE, or the tool chain. Now, the solutions for that is to use the latest versions of the Arduino IDE or ESP-IDF, as well as up-to-date ESP32 board definitions, right? Confirm library compatibility with the ESP32. Some Arduino libraries are not ESP32 ready without modification. Okay, another troubleshooting is the Wi-Fi connection problems, right? Causes could be a typo in the SSID/password or a weak signal or router incompatibility. The solutions for that is to double check Wi-Fi credentials, right? Place your ESP32 closer to the router and ensure router supports mixed modes, not just the 802.11 and only, right? So those are the kinds of things that you want to look into when it comes to troubleshooting. However, that's what I have for you today. Please take a moment right now to hit that subscribe button and like button. If you appreciate this video and you want more videos like this, please let me know that by hitting that subscribe button and the like button right now. I appreciate your viewership. Stay safe and see you on the next video.